Okay, welcome to AP Statistics. We're going to be taking a look at data in Unit 1, exploring it and making sense of the data that we have collected. What exactly is statistics? Statistics is the science of data. There is a volume of data that's almost overwhelming that we can collect. So for example, the checkout scanners at Walmart's 10,000 stores in 27 different countries record hundreds of millions of transactions every week. So if we wanted to take a look at the data from Walmart's store scanners, it could almost be overwhelming. So we have to figure out a way to make sense of that large amount of data that we have collected. In all of the cases that we look at, data is always trying to tell us a story. What story is it telling us about the Walmart shoppers? What exactly are they purchasing? Do they spend more money on a Wednesday or a Friday? So to hear exactly what data is saying, we are going to help the data speak by organizing, displaying, summarizing, and asking questions about the data. That's called data analysis. Okay, so in this section, we are going to be taking a look at data analysis, how exactly can we make sense of the data that we have collected. In this PowerPoint, we're just going to get a basic introduction of data analysis. After this section, you'll be able to understand what individuals and variables are, distinguish between categorical and quantitative variables, define and understand what a distribution is, and what exactly the word inference means. All right, so let's start out talking about what we said at the beginning. Statistics is the science of data. And just like science has to explain the information to you as students, to people that just want to read and learn about science, statistics is the science of data. So when we are collecting, analyzing, and looking at this data, the goal of that is to be able to present the data to the public or someone walking down the street presenting it to your mom, dad, brother, or sister, so they can understand the story that the data is saying. So not only is this going to be a math class, but this class is also a quote-unquote English class in the sense that you will have to be able to explain your data so that somebody walking down the street understands exactly what that data is saying. So that's basically what data analysis is: taking a look of a large amount of data, being able to organizing, display it, summarizing, and asking questions about the data that make sense. So we want to be able to display the data in a way that it can tell its story very easily. So in order to start out statistics, we have to understand the difference between what an individual and a variable is. So an individual is the objects that you're studying. They don't necessarily have to be people. We can be studying trees in this forest, how many cars are passing through a specific intersection, do M&Ms is there equal amounts of red, green, blue, and brown M&Ms in a bag? Oftentimes you'll hear them called cases. Most of the time we'll be using the word individuals. A variable is any characteristic of the individual. So the individual is the big picture that we're studying. The variable is a characteristic that individual holds. So for example, it could be hair color, it could be shoe size, it could be how many leaves are on a specific tree, the number of siblings that we have. Okay, so those would all be characteristics of that individual. Now, for different individuals, the variable can take on different values. So two different people, one can have blonde hair, one can have blue hair. Okay, so within the category of variable, there are two different types of variables. One is a categorical or qualitative variable. So what that is that places the individual into one of several groups or categories. So think about having a bunch of bins, and if you could place that person in one of those bins. So for example, hair color. So you could have brown, blue, blonde, and red. When I take a look at that variable, hair color, okay, I can place that specific person in one of those bins. This is sort of our non-mathy version. Okay, another example could be the area code. Oh, well, area code is kind of mathy. So in a minute, we're going to take a look at see how area code is not necessarily mathy. Okay, think of it as a bin. You can have an area code of 703, 412, putting somebody into that specific bin. Okay, so the mathy version of variables is a quantitative variable. So think of quantitative has an N in it, it's more numerical. They take on numerical values which make numerical sense. So for example, to find an average, okay, to find the median, to find the lowest, to find the highest. So the average number of siblings, the average shoe size, what's the smallest shoe size, largest shoe size, what's the average number of songs on your iPad, what's the average length of songs on your iPod. Those you can find, it makes sense to plug them into your calculator and find numerical averages with them. Over here, you can't really plug this information into your calculator. It's not going to make numerical sense if you do data analysis on them. All right, so let's just take a look. Let's take a quick example of getting some practice with individuals, variables, and deciding whether they are categorical or quantitative. If you are struggling after you try this problem, please watch the video 1.1 Census at School Data. It explains the differences between individuals and variables and is right under the 1.1 content in Blackboard. So what I would like you to do is just take a minute, read this scenario. Once you've read this scenario, I would like you to answer the questions: what are the individuals in this study, and what variables did Rohan measure? Please then identify each as categorical or quantitative. Okay, so just take a minute, pause this, and once you're done, move on to the next slide. Okay, so see how you did. What are the individuals in the study? So remember, the individuals are the big picture that you're studying. Okay, so the individuals are all of the bikes in the parking lot that Rohan looked at. What are the variables that Rohan measured? So within each individual, he took a look at specific things. So the variables are the specific things that Rohan measured. And then we want to be able to identify them as categorical or quantitative. This is going to be really important, understanding the difference between categorical and quantitative, and we'll go over that in a minute. So what did he take a look at? All right, he took a look at the make. So was it BMX, Schwinn, Trek, okay, what model, what version of that bike did he buy, and the color. So think about again, those are bins. You can put them in various bins. Did it have a speedometer or not? Was it a mountain bike or a road bike? So those are the characteristics of the bikes he was looking at. What are the quantitative variables? So quantitative has an M, it's very numerical. Okay, the weight and the number of gears. All right, so we can find the average of the weight. We can find the lowest weight, the highest weight. How many gears does it have? What's the average number of gears? What's the median number of gears? Those all make sense to collect numerical data on them, to plug them into our calculator and do numerical analysis on them. All right, so what's important for the AP exam? What do we need to know about distinguishing between categorical and quantitative variables? All right, so here's your first AP exam tip. If you learn to distinguish between categorical and quantitative variables now, it's going to be much easier later on. On the AP exam, you're going to be expected to analyze categorical and quantitative variables correctly. What does that mean? That means that you're going to have to be able to understand how to correctly graph categorical and quantitative variables, which graph do you use for each, how to organize them in a table. You use different types of tables for categorical versus quantitative, and how you are going to test them, okay, because you're going to use different tests whether you're dealing with categorical or quantitative data. So there is a little bit of a trick to categorical data. It doesn't have to be non-numerical. So it doesn't just have to be the color of your hair, the color of your shoes, the color of your house. It can be numerical. Okay, so let's take a look at some categorical variables that are numerical. All right, so for example, zip codes are numerical, but they're also categorical. Your year in school, 9th, 10th, 11th, and 12th grade, those are numbers, but they're describing sort of like a bin. Think of it as a bin again. So the 9th grade bin, the 10th grade bin. It doesn't really make sense for me to find the average grade that you're in. 9.5 grade, well, that's not really a grade. You never report that. You would say I'm in 9th grade, 10th grade, 11th grade, 12th grade. We might group people based on a range of ages. Okay, so if we were doing individual ages, that would be quantitative, but a range of ages is a group. We don't know what the average is between 0 and 9, so it doesn't make sense in order to take the average of groups of ages. Phone numbers, finding the average phone number doesn't make sense. The lowest or the highest phone number, that doesn't make sense to plug on your calculator. What's your classroom number? And your birthdays. So think of some other examples that would be non-numerical but would also be categorical. Okay, so just remember, in order for them to be quantitative, you need to be able to do numerical analysis on them. Like I said, take an average, find the median, what's the lowest, what's the highest. If you're still having a little bit of trouble or you want to see a few more examples, there is a worksheet in Blackboard right underneath the 1.1 content that will give you some more differences between quantitative and categorical variables. Okay, so take a minute. This is just a multiple choice question for you to understand, to see if you understand the difference between quantitative and categorical variables. So you record the age, marital status, and earned income of a sample of 1,463 women. The number and type of variables you have recorded is the following. How you did. Okay, so the answer is letter E. It is quantitative. There are 2 quantitative and 1 categorical. So let's look and see. We did age, marital status, and earned income. Okay, so age I can take the average of, earned income I can take the average of. Okay, so those are both quantitative. So there are 2 quantitative and 1 categorical. Marital status is categorical. So the answer was letter E. Okay, does it make sense to plug it in on the calculator? Okay, so a variable can take on many different values. So for example, when I was talking about hair color, you could have blonde, brown, blue, black hair. In data analysis, we're interested in how often a variable takes on each value. So a distribution tells us what values a variable takes on and how often it takes on those values. So basically, we're just taking a look at the different variables and placing each individual into one of those variables. So how many people have blonde hair? How many people have red hair? Okay, so here's an example. We're taking a look at a bunch of cars and looking at their miles per gallon. So let's just think about this for a minute. What is going to be the variable of interest? What are our different individuals? Okay, so our variable of interest here is the miles per gallon. That's what we're analyzing. The individuals are going to be all of the different cars that we took a look at. Okay, now miles per gallon, what is this going to be? Think about it. Categorical or quantitative? This is going to be quantitative because I can find the average miles per gallon. How can we show the distribution of all of these values? We can do it using a dot plot. Now notice your dot plot here takes a look at the variable of interest at the bottom. We're taking a look at the miles per gallon, and we're taking each one of our individuals and putting them on the dot plot. So we can very easily see how the data is distributed, exactly what it looks like. What's the lowest data value? What's the highest data value? Where are most of the data located? They're located in the middle. Okay, so how exactly do we explore data? The first thing you want to do is look at each variable by itself. Okay, so this specific example, we're taking a look at the miles per gallon. Then we're going to take a look at the relationship among the variables. In this case, we only have one variable, so we're only looking at the relationship between each of the individuals. How would we take a look at the relationships among various variables? So the first thing you're always going to want to do is start with a graph. So a graph gives us a visual representation of of exactly what that data looks like. Then we're going to add numerical summaries, and we'll work on this later on in the next couple of sections, but they are able to tell us what is the mean, what's the median, what's the standard deviation. Hopefully you've heard those words from Algebra 2 before. We'll take a look at the numerical summaries. Now remember, if you have categorical data, you probably won't be able to have those numerical summaries, but you want to be able to show the distribution of your graphs or the distribution of your data in some sort of graph. All right, so why exactly do we collect this data? Why do we need to show graphs of the data? Why do I need to give numerical summaries of the data? The reason that we do this is in order to do inference. So what exactly is that word inference? Inference is when we're interested in drawing conclusions beyond the sample data. Think about drug companies. If drug companies are going to do a study, they're going to study a small population. They're not going to take everybody in the entire world. If we're taking a look at a drug that's looking at lowering blood pressure, we're not going to take the entire world and do a test on the whole world. That doesn't make sense. So we want to draw conclusions beyond the sample. So we want to take a sample and then use that sample in order to make conclusions for the entire population. So let's say we take a sample of 100. Okay, so just take a minute and see if you can practice what you've learned. So which of the following is an example of inferential statistics? So remember, inferential statistics is gathering a sample and then making a conclusion about the entire population. So if you need to, pause the recording, read it, take a look at your answer, and then we'll check your answer on the next slide. Okay, let's see how you did. The answer was letter B. So from letter A, we have our entire class math grade, and we're calculating the average math grade for the whole class. Well, that we don't need to do inference because we already have the entire population of our class. Okay, so we have the whole population, so we don't need to do inference on it. Okay, so we have our entire math class grade, and we use the grades to find an average from everyone in the school. So we're using our sample to make a conclusion about everyone in the school. That is inference. We're inferring something about the population from the sample. In this case, the population was just your school. Okay, so we have our entire math class grade. We use these to estimate the average grade for the same math course at another school. Okay, that's also inference because we are making a conclusion about a different population based on our sample. Okay, so what I would like you to do is you're probably going to have to pause the PowerPoint for a minute and read this. This is going to be an activity that you are going to do with the discussion board. So please take a minute and read it. Okay, once you've read it, please follow the instructions from step 1 and step 2. You are then going to fill out the Google Doc, which will also be posted in Blackboard, with the number of females you got from step 1. Okay, so what you're going to be doing after you read this is we're going to be asking a question about possible discrimination. So we want to decide, based on this information, was there discrimination in this case? Now, look at what the question says. Is it plausible or believable, you'll see those words a lot, that these results happened by chance alone? Well, what does that mean? If they were happened by chance alone, that means the company was not actually discriminating, and it was just since there's a various probability of choosing different male and female pilots, it just so happened by chance alone that this is the results that they got. Or if it did not happen by chance alone, that means there was some sort of discrimination in the hiring process. Okay, so to find out, your classmates and yourself will simulate the lottery process doing the following. Please rip up 25 pieces of paper, put an M on 15 and an F on 10 of them. Put them in a bag and a hat and mix it up. Without looking, please remove 8 pieces of paper from the bag and count the number of female pilots you selected. Okay, so was it close to that 5 or was it a little bit different? After you're done with that, please fill out the Google Doc below with the number of females you got from step 1. This will also be on Blackboard. Okay, and we're going to compare this to the rest of your class to decide, hey, was that just happened by chance alone, or is there actually some discrimination? Okay, so we're going to be looking at the answer to this pilot question as part of your discussion board. Make sure to check your assignment sheet for instructions. In the next section, we're going to take a look at bar graphs, pie charts, two-way tables, and conditional distributions. I'll explain what the last two are as we go through the next section.